Okay, so I'm going to continue now on pages 15 and 16, but we do need the graph from page 14 to do those problems. So, oops, I forget how to run this. So, if you look at NaCl, that is the blue one, the blue line down at the bottom. So, go to 50 degrees, right down here, and go up to that blue line, and then when you take it over to the side, it's about 10. So down to 10, right here. KCl is the green one, that's about 30. NaCl, how much is going to dissolve? Go to 80, go up to the blue line, that's about 39. Well, let's go back to that graph. Which one's the least? That'd be your blue. Which one's the most? That'd be your red if we're looking at 60 degrees. So the most is going to be KCl's green at 75, right up, hits the green line, is about 48. Graph at 70 degrees. I'm going to erase this. At 70 degrees, and of course, my short-term memory is not there, so I forget what we're looking for. Okay, so 70 degrees right here. We're going up to the green line, KCl, and that is, I'm going to say 48. Okay, so where on that KCl line do you hit 38 grams? And so you start riding that green line down until you get, I'm going to say, it's right about here. Okay, and so what temp is that? 32. So what I did was I knew that 48, okay, 48 dissolves up there, and they want 10 to crystallize, which means I have to drop it down to 38 solubility. So I ride the line down until I find 38. And then that is about 32 degrees where that's going to happen, or where that's the solubility. So everything else would fall out into, let's go back and look at that. I'm afraid to do that bottom one. 40 grams of KCl at 80. Oops, 40 grams of KCl. Okay, that's about there. Okay, well, how much can we do at 80? We can actually do about 50. So this would be underneath, okay? 40 grams would come across, and we should actually be able to do 50. 120 grams is right here of KNO3. We need to be at a temp of, holy man, I can't draw. At 60 degrees, you can only do 105. So if we put 120, 50 degrees, we ride up, that's 80 right on the line. So anytime it's right on the line, that those two temps. KNO3 is my red line. Okay, again, I'm going to erase this. 50 and 65. Okay, at 50, I can do 80. Is that right? And at 65, I can do 115. So 115 minus 80 degrees. KCl's green, and I'm going to 75. That's going to be about 48. All right, so let's take a look at question number 12. What's the solubility of NaCl at 39 grams? 39 grams of NaCl And if you really were to write this, it's NaCl per 100 grams of water. Okay, solute and the solvent to make an aqueous solution. Number 13. Sorry. What's the solubility of KCl at? So I would fill in 30 grams. Okay, 14. If 50 grams of NaCl is mixed with 100 grams of water at 80 degrees Celsius, how much will not dissolve? Okay, couple things here. This is kind of the afterthought. I would always make sure that you're in 100 grams of water and they're giving you 80 degrees Celsius. So first check that it's 100, then go to your temp. And what are we looking at? We're looking at NaCl. So at 80 degrees, okay, so this is 39 grams. Well, if they put 50 in, how much is not going to dissolve? You'd have to go 50 minus 39 equals 11. That's ugly. 11 grams that would not dissolve. Which substance is the most soluble at 60 and which is the least soluble at 60? Potassium nitrate. And the least is going to be that NaCl, sodium chloride. How much KCl is needed to saturate 50 grams of water at 75 degrees? So this is your proportion again. Look what's changing, that 50 grams of water. So I always say start with your 100 grams of water and find how much solute can go in. And of course, you use the temperature to do that. So KCl at 75 degrees, okay, so that's 48 grams would dissolve in 100. Well, if they switch that to 50 grams of water, how much will dissolve then? And so this is a cross multiplication and division. 50 times 48 divided by 100 equals 24 grams. Okay, or just look that someone's cooking on the other side of the wall. The water's being cut in half, so then the solute would be cut in half. Number 17, 100 grams of water saturated with KCl at 70. Okay, so this is your standard on the graph. KCl at 70. To what temperature must the solution be cooled if we want 10 grams to fall out? So let's go back to KCl. So at 70 degrees, you can get 48 grams to dissolve. If we cool it down, okay, we're looking for this number so that 10 grams will crystallize. Okay, so what do we have to take that down to? That would be, what's X? 48 minus what equals 10? 38 grams. So this one is 32 degrees. Assume that all of the following can form supersaturated solutions. Okay, we form supersaturated by heating them up to a higher temperature, because the higher the temperature, the more you can dissolve, but then it's super unstable. So indicate whether the following solutions are saturated, unsaturated, or supersaturated. So 40 grams of KCl at 80, that one is unsaturated. 120 grams of KNO3 at 60, and that means it's saturated. It's a supersaturated. 80 grams of KNO3 and 100 grams at 50. So KNO3 again, and we're looking at 80 grams. Can we do 80 grams at 50 to be saturated? So when you have your curve, if your dot is over it, it's supersaturated. If it's on it, it's saturated. And if it's under the curve, according to your temp, it's unsaturated. If a solution of KNO3 is heated from 50 to 65, how much more will dissolve? You need to figure out how much can dissolve here and how much can dissolve here. So KNO3, what are my temps? 50 and 65. Because this number is 115, this one's 80. So I'm going to subtract them to see how much could be dissolved just by heating it. 115 minus 80 equals 35 grams. How many grams of water are required to dissolve 20 grams of KCl at 75? Now, they're asking for the amount of water. So the one we know, my y-axis, is 100 grams of water. Okay, looking at KCl, and here's my temp. So how much KCl in 100 grams of water at 7? Okay, and this is your KCl. Solute over the solvent. Okay, so what if we change that solvent to only, oh, I'm lying. That's what we're solving for. We want to see how much solvent, how many grams of water. For 20 grams of KCl. Okay, cross multiply and divide. 100 times 20 divided by 48. Calculator. 100 times 20 divided by 48 equals 41.67 grams of water. Okay, let's go to page 3. This one's looking at gas. So every one that we've seen, you know, where it was an ionic solution, you see that as the temp goes up, the solubility goes up. Gases are just the opposite. As the temp goes up, the solubility comes down. So what's the solubility of oxygen in 1 liter? This is the oxygen in 1 liter, and the label is milligrams at 24 degrees Celsius. So just go to 24, right up the line, then you come across, and I would call that 8.5. And your answers, my answers on here might even be different than the key I posted because it just depends on the day, how straight your line is, what device you're using. And I would call this grams per liter. At what temperature is the solubility of oxygen? 10. So where do we hit 10? You got to go to 10, come over, drop down, and I would say roughly about 16 degrees Celsius. What mass of oxygen can be dissolved in 2 liters of water? So they're doubling the water. Okay, so the curve is for 1 liter. They now want to double it to 2 liters. Here's your temp. So when we look at the 1 liter at 30, we can do about 7.5. So if I double, or I go 7.5 times 2 divided by 1 is 14 milligrams of oxygen. What's the relationship then of the solubility of a solid? Okay, it's a direct. That's this guy. As the temp goes up, the solubility goes up. We have a positive slope. What's the relationship between temp and the solubility of a gas? And that's going to be inverse or indirect. Inverse. As the temp goes up, the solubility is going to come down.